In our lesson today, we're going to learn how to add and subtract mixed numbers. So if I wanted to add 4 and 3/8 plus 1 and 7/8, sometimes a picture will help me to do that. So here's my picture. I've got 4 whole pies and 3/8 of another pie. And I'm adding that to 1 whole pie and 7/8 of another pie. Now when I'm adding them, I'm combining them. I'm putting them together. So what that means is, if I were putting these together, I can fill this empty space in this pie here with 1/8 of a slice that I take from this piece. Okay, so now I can see that I would have 1, 2, 3, 4, 5, 6 whole pies, and I would have 2/8 of a pie as well. 6 and 2/8 is how much 4 and 3/8 plus 1 and 7/8 would be. Let's see if a picture would help us subtract 5 and 7/8. So there's my picture. I've got 5 whole pies and 7/8. And I want to subtract 2 whole pies and 3/8. 1, 2, 3. Okay, I can see what I have left. I have 3 whole pies and 4/8 of a pie left. So there are times when a picture is helpful for adding or subtracting mixed numbers. However, have a look at this situation. 5 and 3/8 is what my picture shows, and I want to subtract 2 whole pies and 7/8 more. Well, I can subtract the 2 whole pies, but then I run into a problem when I'm trying to subtract 7/8 more. I have 3/8, I don't have 7/8. I can guess where 7/8 would be on a pie, but there has to be another way to subtract mixed numbers. Okay, so think about the question that we had a minute ago. 5 and 3/8, and I wanted to subtract 2 and 7/8. Well, 5 and 3/8 looks like this. But I can actually show it a different by just dividing one of those whole pies that I had, one of those 5 pies, into its 8 pieces. I can show that exact same fraction as 4 and 11/8. It's still the same amount of pie. You can see from the picture that it's the exact same amount of pie. I've just divided this one pie up into its 8 pieces. So I've got 8/8 plus 9/8, 10/8, 11/8. So I've got 11/8 here altogether, but it's still the same amount of pie that I had when I had 5 and 3/8. Those are equivalent fractions. Okay. So back to our original question. Our original question said 5 and 3/8 minus 2 and 7/8, but I've just divided one of those pieces of pie, one of those whole pies up into its 8 pieces. So I have those 8 pieces plus these 3 pieces to make 11 pieces. 11/8. Now it makes it a little bit easier to subtract. I have 4 pies and 11/8, and I can subtract 2 whole pies and 7/8. 1, 2, 3, 4, 5, 6, 7. Those pies are all gone, those pieces. So now what do I have left? Well, I have 1, 2 whole pies and 4/8 left. Which makes sense when you look at the question here and look at the answer that I got when I reconfigured one of those pieces of pies and divided it up into its 8 pieces. Look carefully. I had 4 wholes. I subtracted 2 wholes. 4 minus 2 is 2. I had 11/8 minus 7/8. Well, they're both 8s, so my answer will still be 8s. What's 11 minus 7? 4. Hmm. I think you've just discovered another way to subtract or add mixed numbers without even needing a picture. Once in a while, though, instead of having fractions that have the same denominator, you have fractions like this, where you are adding 2 and 2/7 and 4 and 1/2. In this case, the denominators are not the same. I know then that I can't add them or subtract them unless they have the same denominator. So I first have to make a common denominator, just like we were doing last day, by changing the fractions to equivalent fractions. All right, so let's look at what this would look like. So I would write, that would be the same thing as 2, and now I need to figure out, I'm just looking at the fractional part of both of these mixed numbers. So I'm looking at this 2/7 and this 1/2. And I need to find a common denominator, a number, the lowest number that both 7 and 2 will go into. So remember, I need to think of my multiples of 7. Okay, so multiples of 7 would be 7, 14, 21, 28, on and on and on. My multiples of 2 would be 2, 4, 6, 8, 10, 12, 14, and on and on. Okay, I'm looking for the lowest common multiple. Well, you can see right away the lowest one that they would both 7 and 2 will go into is 14. So that's what I would use as my common denominator. So I'm going to change 2/7 into 14ths, and I'm going to do the same thing with 1/2. I'm going to change it into a denominator of 14 as well. Okay, so now I'm going to use what I've learned about equivalent fractions to be able to do that. So what have I multiplied my denominator of 7 by in order to get a denominator of 14? Multiplied by 2. So I have to do the same thing to the numerator. I have a 2 in the numerator, so 2 times 2 is 4. So 4/14 is equivalent to 2/7. Okay? Same thing with my half. I have to do the same thing. I have to convert it to a fraction that has a denominator of 14. So what have I multiplied my 2 by to get 14 as my answer? 2 times 7. So I have to do the same thing in the numerator. 1 times 7 would be 7. So I have 2 and 4/14 plus 4 and 7/14. Now I have both of my fractions with a common denominator of 14. Now I can do the adding. Okay, I'm just going to add, like I saw in the last example, the whole numbers together. So 2 plus 4 is 6, and now I'm going to add the fractional parts together. 4/14 plus 7/14. Well, it's going to be 14ths. The denominator never changes. And 4 plus 7 is 11. So my answer is 6 and 11/14. Let's try B. I have 4 and 2/5 minus 1 and 1/6. Okay, well, I know that my 4 is not going to change. My 1 is not going to change. My whole numbers will not change. It's just the fractions. I can't add fractions unless I have a common denominator. I can't subtract fractions unless I have a common denominator. So I'm looking for the lowest number that both 5 and 6 will go into. Okay, so again in my head I'm going to think, well, 5s would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 6s would be 6, 12, 18, and on and on. Okay, what is the lowest common factor that both of those numbers will go into? 30 is the lowest one, so I'm going to turn both of those fractions into 30ths. Okay, let's see what I would have to do in order to go from a denominator of 5 to a denominator of 30. What if I multiplied this 5 by to get 30? 5 times 6. So I do the same thing on the top. 2 times 6, 12. 4 and 12/30 is equivalent to 4 and 2/5. Okay, let's do the same thing with 1 and 1/6. What have I multiplied this 6 by to get 30? 6 times 5, right? So multiply the top by 5. 1 times 5, 5. Okay, now I can just do the subtraction. Again, I'm just going to subtract the whole number parts. 4 minus 1, which is 3. And now I subtract 12/30 minus 5/30. Well, it's still 30. 12 minus 5 is 7. 3 and 7/30. I'd like you to pause the video and try the next two on your own. And then once you have an answer for both of them, restart the video and check your work. Okay, there are the answers. Check your own and see how you did. Okay, sometimes when you add mixed numbers like this, you will get an answer that is not in simplest form, or as we called it the other day when we were learning to do this, in lowest terms. Okay, when you put a fraction into lowest terms, that's called simplifying the fraction. You're putting it in simplest, lowest terms. So let's try a couple where we're going to add the mixed numbers together. We're going to end up getting an answer that can be simplified so that we can review how to simplify or reduce a fraction. Okay, so I have 1 and 1/2 plus 2 and 2/3. So I've got 1 and some fraction plus 2 and some fraction. But I notice that those fractions do not have a common denominator, so I need to make a common denominator. I'm looking for the lowest number that both 2 and 3 are multiples of. Hopefully you determined that that would be 6. Okay, so now I need to look at what have I multiplied 2 by to get a denominator of 6. 2 times 3, so I do the same thing on top. 1 times 3 is 3. Okay, do the same thing on this side. What have I multiplied 3 by to equal 6? 3 times 2, so I do the same with the numerator. 2 times 2, 4. Okay, 1 and 3/6 plus 2 and 4/6. Well, I'm going to add first my whole numbers out front. So I have 1 plus 2, which is 3, and then I have 3/6 plus 4/6, which is 7/6. When I look at that, I notice that I have an improper fractional part. Okay, I have a bigger number on top in the numerator than in the denominator of the fraction 7/6. So that means that this fraction needs to be simplified. It needs to be put into lowest terms. Okay? What this really means that I have is 3 wholes plus 7/6 more, right? Now I'm going to use what I know about converting improper fractions to mixed numbers. So this 7/6 is really 1 and 1 more 6th, right? 1 whole would be 6/6, and I have 7/6. So I have 1 whole and 1 more out of 6. I can double check my work by going 6 times 1 equals 6, plus 1 is 7, right? So I can just recheck it really quickly in my head. So 7/6 is 1 and 1/6. I've got 3 plus 1 and 1/6, which would really be 4 and 1/6. Okay. Now this fraction is simplified. I have a mixed number still, but my fractional part is a proper fraction with a lower number on top, a greater number on the bottom. Okay, let's try the second one. 3 and 5/8 plus 4 1/2. Okay, well, I have 3 and some fraction plus 4 and some fraction. I'm looking for the lowest number that both 8 and 2 will go into, or are multiples of. Well, they'll both go into 8, won't they? So this one is easy. I can just leave that as 5/8. It's already 8s. This one, 1/2, I can write it as an equivalent fraction with 8 as the denominator. What if I multiplied 2 by to get 8? 2 times 4. So I do the same with my numerator. 1 times 4 is 4. Okay, now I have 3 and 5/8 plus 4 and 4/8. I'm going to add my whole numbers out front first. So 3 plus 4 is 7. Now I'm going to add the fractions. 5/8 plus 4/8 is 9/8. And again, I notice that I have an improper fraction. I have a greater number on top. So that means I need to split it apart, as that means 7 plus 9/8 more. And then that 9/8, I'm going to rewrite it as that's 1 and 1/8. Okay, I can double check really quick. 8 times 1 is 8, plus 1 is 9, 9/8. So 7 and 1/8, or 7 plus 1 and 1/8, I mean, is 8 and 1/8. Okay, we're going to rewrite each of these mixed numbers to make the improper fraction a proper fraction, just like we were just doing a minute ago when we were simplifying. So this would really be 3 and 7/6. And I know that 7/6 can be rewritten as 1 and 1/6. So now I can add that together. I have 3 plus 1, which is 4, and 1/6. 2 and 4/3. Well, that's really 2 plus 4/3 more. I know that can be written as 2 and 1 1/3, right? So I can add that together now. 2 plus 1 is 3 and 1/3. And the last one, 3 and 10/9 is the same thing as 3 plus 10/9 more. 3 plus, well, that's 1 and 1/9. So I can add my whole numbers now. 3 plus 1 is 4, and I have 1/9 more. Okay. So now we're going to add these fractions by changing the fractions to equivalent fractions that have common denominators, because I can't add them unless they do. And in some cases, I may have to simplify or put my fraction in lowest terms. Okay? So let's see, I have 2 and 2/5 plus 2/3. Well, when I look at the fractions, I'm looking for the lowest number that both 5 and 3 are multiples of. 15. I'm going to have to change both of those fraction parts to 15ths. Okay, so what have I multiplied 5 by to get 15? 3. So do the same on the top. 2 times 3, 6. And my other fraction, what have I multiplied 3 by to get 15? Multiplied by 5. So 2 times 5 is 10. Okay, now I can add that. I have 2 as my whole number, and I have 6/15 plus 10/15, 16/15, which again needs to be reduced. So that's the same thing as 2 and 1 and 1/15. That's what 16/15 is, right? Multiply it in your head. 15 times 1 is 15, plus 1 is 16. 16/15. And that's the same thing as 3 and 1/15. Okay, let's try this one. I've got 4 3/4 plus 2 3/5. Okay, well, I'm looking for the lowest number that both 4 and 5 would be multiples of. The lowest thing they'll both go into is 20s. All right, so what have I multiplied my 4 by to get 20? 4 times 5. So do the same on the top. 3 times 5, 15. Okay, same thing. What have I multiplied 5 with to get 20? 5 times 4. So 3 times 4, 12. Okay, now when I add, remember I'm adding my whole numbers out front first. 4 plus 2 is 6. Now I add the fraction part. 15 twentieths plus 12 twentieths is 27 twentieths. Again, I notice that I have an improper fraction, a greater number in the top of my fraction, so I need to split it apart. That's the same thing as 6 and 27 twentieths, which I can change to a mixed number. That's 6 and, well, 20 goes into 27 one time. How many do I have left over? 7 twentieths. Multiply it quick in my head to double check. 20 times 1 is 20, plus 7 is 27. Okay, so I know I'm right. Now I can add my whole number parts. 6 plus 1 is 7, and my fractional part, which is 7 twentieths. Okay, that is the end of our lesson for today.